Good morning, my dear students. We move to another module, that is metallurgy. It is a chapter to observe how metals are available or extracted to the present form. So, we have to define what is metallurgy. It is defined as the process used to extract metals in the pure form from its ore, O-R-E, ore. So, metals are in a combined form, and by various processes we extract them to pure form. That whole process comes under the heading metallurgy, and it encompasses the area that studies the physical and chemical behavior of metallic elements, their intermetallic compounds, and their mixtures called alloys. All these come under the heading metallurgy. The extraction of metals or metallurgy comprises of three different headings. One is the concentration of the ore. Second is the isolation of the metal from the concentrated ore. And third heading is the purification of the metal. So for any extraction of any metal, these three processes are carried out one by one. This is the whole process actually happening in metallurgical process. Take down. In the crust of the earth, metals are present in two forms. One is in the native state and another in the combined state. And in the native state, very few elements which have very low reactivity with other elements and radical ions remain as such without formation of complex compounds. Such type of elements which have low chemical reactivity or noble metals having least electropositive character are not attacked by oxygen, moisture and CO2 of the air. So they usually remains almost in a purified form without the formation of any carbonates or oxides or hydroxides, etc. But majority of the elements in the earth crust exist as combined state. That means these elements are highly reactive and they easily combine with oxygen, halogens and other elements to form their corresponding oxides, carbonates, sulphides, etc. That means they remain as compounds rather than in the native form. Now see these terms: minerals and ores. Minerals and ores. The naturally occurring substance in the form of which the metal occur in the earth crust are called minerals. majority of the metal, they combine with oxygen, carbonates, water, and exist as carbonates or oxides or hydroxides. Or some exist as chlorides, fluorides, and halides. So they are existing in the earth crust as a combined form. They are called minerals. But we cannot extract metal from all minerals. Certain minerals are suitable for the extraction economically, while some other are not suitable for extraction. The mineral form which the metal is economically and conveniently extracted is called an ore. That means all ores are minerals, but all minerals are not ores. That means we use some of the minerals for the extraction of metals and they are called ores. The impurities that is associated with the ores are called gangue or matrix. So for any mineral in the combined form, it could be converted as a ore or it could be classified as an ore, and any ore it is associated with some impurities and that impurities are called gangue or matrix. Then we have a particular substance called flux. Flux is a substance which is added to the ore so that it combines with the gangue and is removed as the slag. So ores contain gangue material. We could remove easily the gangue by adding certain materials called flux. These are chemical compounds. And the flux combined with the impurities present in the ore and it will be removed as slag. So slag is a combined form of flux and gangue. Take down. So the entire metallurgical process are basically classified into three types. That depends upon the technological process used for the separation of the metals. The first one is pyrometallurgy. Pyrometallurgy. From the name itself, we could make it out. It is the metallurgical process happens at high temperatures because certain metals has to be extracted using pyrometallurgical considerations. For example, copper, iron, zinc, tin, etc. are extracted by pyrometallurgical process. The second type is called hydrometallurgical process. Hydro means water. So in hydrometallurgical process, the metals are extracted by the use of their aqueous solutions. Example, silver and gold, Ag and Au are extracted by this method. The third one is electrometallurgical process. Electrometallurgical process. Metals like sodium, potassium, lithium, calcium, alkali and alkaline earth metals are usually extracted from their molten salt solution by electrolytic process. So these are the three processes used for metallurgy. They are pyrometallurgy, hydrometallurgy and electrometallurgy. We move towards the metallurgical process. In any metallurgical process, the first process is the mining of the ore material. and these ore materials are crushed into smaller portions. When we mine any ore material, it will be in a lump form or a bulky form. So we have to change them to powdered form for the remaining metallurgical process. So the big lumps of the ore are crushed with the use of crushers, and they are grinded using grinding machine to have powdered form. This is the first process that occurs in metallurgical process, that is the crushing of the ore. Once the crushing of the ore is over, we move to the second process, that is called the concentration of the ore. In concentration of the ore, we have to remove the unwanted materials like sand, clay and other impurities, so that the percentage composition of ore material has to be increased. This process by which the ore concentration is increased is called concentration of ores. Various methods are used for the concentration of ores, and these methods are used for different types of ores. Take down. So we move to the different process for the concentration of ore. As I told you, concentration of ore is the process of removal of the impurity or gangue material from the ore and to increase the concentration of the metal and its compounds. The first method is hydraulic washing. Hydraulic washing is the simplest process, where see here in the picture we have the powdered ore here, and we will add water from top, so that in this water this powdered ore will float. Heavier ore particle will settle in the first tank, while the lighter particles will overflow from this tank and settle in another tank. If the ore is the lighter particle, heavier impurities settle here and the ore will be collected in the next vessel. So whether the ore is lighter or the impurity is lighter, here we could increase the concentration of the ore by hydraulic washing. So here water is passed through the ore and different impurities and ore are collected in different sections. This is hydraulic washing. Now the second method is magnetic separation. Magnetic separation. And this magnetic separation is used for separating magnetic particles, whether it is impurity or ore. If the ore is the magnetic particle, it could be separated using magnetic separation. If the impurity is having magnetic character, it could be separated by magnetic separation. We pass the ore and the impurity through conveyor belt. See here, this is the conveyor belt. We pass the ore material here. So this ore material will pass through the conveyor belt, and this is the magnetic rollers. So what happens? If the ore particle is having magnetic attraction, it will be attracted and fall on this collector. If the impurity is the non-magnetic material, it will directly fall on this collector, so that we could separate the non-magnetic impurity and the magnetic ore particle. That is the process of magnetic separation. Take down. Froth to flotation method is another method used for the concentration of ore. Here what we use is certain materials along with the ore. They are froth stabilizers and froth collectors. So what will happen is that to the powdered ore we add water and create a suspension, and to this we add froth collectors and froth stabilizers. Examples for froth collectors are pine oil and fatty acids, and the duty of these collectors are to increase the non-wettability of the metal particle. That means these collectors will not allow the ore material to dissolve or get attached to the water molecule. And the stabilizers are used to increase the stability of the froth so that the froth and the ore particle should remain for a long time. This is the froth flotation method. Once the froth is formed, that froth is removed and it is dried so that we will get the metal particle. See the picture? In this picture we could make it out. Here we feed the ore particle, collectors and froth stabilizers. It will be agitated here, shaken heavily so that the ore particles get into the froth or foam, and these froth are collected here, while the impurities which have high wettability, they get introduced into water and they will be collected here. This process is called the froth flotation process. Another method is leaching. Leaching is a simple technique. What we use is we use a suitable solvent and will dissolve that ore in that particular solvent. Then that solution is extracted and separated by some other extracting process. You got it? In leaching, the ore particle is dissolved in a particular solution. For example, if we are using sodium solutions, sodium hydroxide solution, some of the particles will dissolve in sodium hydroxide solution, and a sodium hydroxide solution of that particle is formed. That metal particle is formed. It is then electrolyzed or leached continuously to get the original metal particle. See here, this is the ore heap and I am adding the leaching solution. This solution will be added here and it will be agitated so that the ore particle will dissolve in that particular solution and it will form a liquid solution. Then it is easily recovered by electrolytic or any other method. This process is called leaching. Take down. So after the concentration of the ore, we are moving to metallurgic process. The first one is the pyrometallurgy. As I told you, in pyrometallurgy, it is the treatment of the mineral and metallurgical ore with some other materials at high temperature. And the metal is dissolved and extracted. Usually metals like iron, copper, zinc, chromium, tin and manganese are extracted by pyrometallurgy. And there are different processes happening in pyrometallurgy that depends upon the ore or the metal we are going to extract. They are calcination, roasting, smelting and refining. These are the important pyrometallurgical process. Take down. The first pyrometallurgical process is calcination. Calcination is the process by which we are converting usually the hydroxides and carbonates by heating at high temperature to the corresponding oxides. That means we take the ore material carbonates or hydroxides and it is heated in the absence of air. That is the important point. In calcination, usually it is carried out without the presence of air or limited supply of air. So what happens? These carbonates, when heated at high temperature, the carbonates decompose to give you oxides and carbon dioxide. That means the moisture and the volatile impurities are removed, resulting the formation of the corresponding oxides. So, for the pyrometallurgical process of metal carbonates and metal hydroxides, calcination is the best process. So, listen carefully. Calcination is the process by which we are converting an metal ore into the corresponding oxide by heating in the absence of air or minimum air supply. That process is called calcination, and calcination is used for carbonates and hydroxide ores. Take down. Another important pyrometallurgical process is roasting. Roasting is almost similar to calcination, except that during roasting process we supply excess of air. In calcination, it happens in the absence of air, while in roasting we use excess of air. And usually sulphide ores are separated by roasting method because these sulphides, when heated at a particular temperature in presence of excess of oxygen, the sulfur combine with oxygen to form sulfur dioxide, which is a gas and volatile, easily escapes out, leaving behind the oxide of the corresponding metal. So at excess of air, excess of oxygen, the sulphide ores are easily converted to the corresponding oxides without reaching the melting point. So the roasting process is opposite to that of calcination. In calcination, no air is used, but in roasting, excess of oxygen or air is used. That is the major difference between calcination and roasting. Take down. Another pyrometallurgical process, smelting. In this process, we are using high temperature. Along with high temperature and the ore material, we add certain chemical reducing agents. So we have the ore material here, chromium oxide. The temperature is very high and we will add certain reducing agent or reducing material like aluminum, magnesium or sodium, so that this metal easily combine with oxygen to form the metal in the purified form. So what happens is that at high temperature, the oxides are usually converted to the corresponding metals. In certain cases, we add certain flux material, so that the flux and the ore or impure metal or combined state of the metal to form the slag, and the slag is removed by other process, so that easily the metal could be recovered. See here, iron oxide, it is combined with the silicon oxide. So what happens, this oxygen from the iron is converted to silicon to form a slag FeSiO3. This, on dissolving or heating, it easily breaks to the corresponding metal and SiO3 as impurity. So in smelting process, it is a pyrometallurgical process. We use additionally a reducing agent. During smelting, in certain cases, auto reduction occurs. See, I am taking cupric oxide, oxide of copper and sulphide of copper. These are minerals or ores, and they on high heating, they easily convert to corresponding sulfur dioxide, leaving the metal. This process is called smelting process. Now moving to reduction of metals using different methods. Once we have obtained the corresponding oxides of the metal, we have to convert those oxide of the metal to the corresponding impure metallic form. So for converting the oxides or sulphides or hydroxides into crude metallic form, we usually carried out reduction. The reducing agents could be carbon, hydrogen, aluminum, or different materials could be used. And we have to see one by one what are the different methods for the reduction of metals that are adapted in metallurgical process. The first one is the carbon reduction process. In carbon reduction process, the metal oxide is treated with the carbon at high temperature in suitable furnace. So what happens? The oxide react with the carbon to form the corresponding carbon monoxide or carbon dioxide, depending upon the carbonaceous material that we are adding. And whether coke, pure carbon or carbon monoxide is needed depends upon the metal oxide that we are using. For example, in case of zinc oxide, we could use a mixture of carbon and carbon monoxide in a smelting furnace or a blast furnace, so that the carbon or carbon monoxide is the reducing agent, which reduces zinc oxide to the crude zinc metal, leaving carbon monoxide and carbon dioxide as the byproduct. So from the oxide form, we are converting to the metal to the crude metallic form by using carbon reduction. Take down. The reduction process is carried out by hydrogen in certain cases. For example, in case of molybdenum and tungsten extraction, we use hydrogen as the reducing agent so that we get molybdenum and tungsten. The major drawback of reduction using hydrogen is that hydrogen is highly inflammable. So, very few cases or for the extraction of very few metals, we use hydrogen as the reducing agents. See here, cobalt, germanium, molybdenum and tungsten. Cobalt, germanium, molybdenum and tungsten. From their oxides, we are extracting to crude metal cobalt, germanium, molybdenum and tungsten by using hydrogen. So, depending upon the metal, we are changing the reducing agents. Take down. Another material we are used for the reduction process is aluminium. And if the temperature needed for carbon to reduce an oxide is too high, the reduction could be carried out by a highly electropositive metal as aluminium, which liberates large amount of energy, and the corresponding aluminium oxide will be formed. And the process is called aluminothermic process or thermite process. And this process is employed where the metals have very high melting and boiling point. Because during aluminothermic process, a huge amount of energy is produced and that energy is further used in the furnace. Metals like manganese, chromium, etc. are extracted with aluminium to form the corresponding metal and aluminium oxides. As I told you earlier, different reduction processes are carried out to convert the corresponding metal oxides or hydroxides to the corresponding metal in the crude form. So for different metals, we are using different reducing agents. So this is aluminothermic process. Take down. For the extraction of certain metals, self-reduction occurs. Self-reduction occurs. That means the oxide or sulphide or hydroxide of the same metal undergoes oxidation reduction process so that the metal will be extracted in the crude form. For example, for less electropositive metals like lead, mercury, antimony and copper, we use the oxides of the same metal so that self-reduction occurs. See here, I have HGS, mercuric sulfide and HgO. So what happens? I will convert this HGS heating in presence of HgO so that they undergo self-reduction to form the metal and sulfur dioxide. So in certain cases, the reduction could be carried out by the oxides or sulfides or carbonates of the same metal ions. I told you, depending upon the metal ore or metal substance oxides, we adopt different reducing agents to carry out reduction process. Very important. Take down. So, my dear students, we have discussed what is metallurgy, what are the different processes of metallurgy, and what are the different techniques or types of metallurgy, and we have seen the corresponding processes happening in each heading. Thank you. We will continue again. Take care. Bye.